This is GCSE Further Maths Pure. We are on chapter 2 and we're learning to solving quadratic equations by completing the square. So first of all, we're just going to look at this expression here. So the secret here is to look at this 8, and if we half that we get 4, and so we want to look then at x plus 4 all squared. So I generally write then consider x plus 4 all squared. So x plus 4 all squared is the same as x plus 4 upon x plus 4, and that gives us x squared plus 4x plus 4x, that's our 8x, that's good, plus 16. We want to rewrite this, so we now have x squared plus 8x minus 5, and we want to rewrite it by completing the square, so it's x plus 4 all squared. Now we know what x plus 4 all squared equals. It equals this. And that has a 16 here in it that we don't want. So because there's a plus 16 here, we go minus 16 and we go minus 5. Rewriting that then will be x plus 4 all squared minus 21. And that's us completing the square then for this expression here. I only use this equal sign here if I really mean it. If I multiply out this bracket and take away 21, I get my original question. So I've rewritten it then in a different form. The next wee bit kind of continues on then from this. This can be used to solve the equation x squared plus 8x minus 5 equals 0. So we know then that that's the same as x plus 4 all squared minus 21 equals 0. Because of our previous page, we worked out that that was the same as that. So what do we do here? We add 21 to both sides. Just kind of try and get the x on its own. We take the square root of both sides, remembering to take the positive and negative value. And then we subtract 4 from both sides. Minus 4 plus or minus the square root of 21. And that's us solving the equation. Of course, you can put that into your calculator and get an answer out to 2 or 3 decimal places. Quite often pure mathematicians like it in that form though, because that's the exact form and that's what we're looking for. Let's take a wee look then at example 2. Excuse me a second. So what are we going to consider this time? We're going to consider x plus 1 all squared. Where do I get the 1 from? It's half of the 2. We know that equals x plus 1 upon x plus 1, which gives us x squared plus 2x, that's outer and inner, plus 1. That's off to the side. So let's look at this. X squared plus 2x minus 5 equals 0. We want that to be the same then as x plus 1 all squared. This gives us a 1 that we don't want. So it's going to be minus 1 minus 5 equals 0. That means we have x plus 1 all squared minus 6 equals 0. How do we solve this? We go x plus 1 squared equals 6. Taking the square root of both sides, x plus 1 is equal to the positive or negative square root of 6, and then subtracting 1 from both sides, minus 1 plus or minus the square root of 6. Example 3. Slightly tougher one here because 7 isn't an even number, but this should be okay. So what are we going to consider? We're going to consider x plus 7 over 2, as in the half of 7 or 3.5, whatever way you want to think about it. That equals x plus 7 over 2 upon x plus 7 over 2. Multiplying out first is x squared plus 3.5x plus 3.5x. That gives us our 7x. And we just need to be careful here. Two last ones. 7 times 7, 4 times 4 gives me 49 over 4. back then over to here, we're going to look at x plus 7 over 2 all squared. This gives us a 49 over 4 that we don't want. So minus 49 over 4 plus 10 equals 0. We want to look to try and tidy this up a little bit. Okay, so x plus 7 over 2 all squared. Take away 49 over 4. I'm going to do a common denominator. Plus 40 over 4. Hope you're okay with that, because that's just the same as 10. That gives me x plus 7 over 2 all squared. Take away 9 over 4 equals 0. X plus 7 over 2 all squared equals 9 over 4. X plus 7 over 2 equals the positive or negative square root of 9 over 4. Now 9 over 4 isn't quite a square number, but we can take the square root of 9 and the square root of 4. So we're going to have x plus 7 over 2 equals plus or minus 3 over 2. And I'll just move that up here. That's going to give me x. It doesn't. That's going to give me, sorry about that, x equals minus 7 over 2 plus or minus 3 over 2. And this tidies up nicely. Minus 3.5 plus 1.5 is minus 2. Or minus 3.5 minus 1.5 is minus 5. Example 4. Again, this is a minus 1, so I'm going to consider x minus a half all squared. That equals x minus a half upon x minus a half. That equals x squared. Outer is minus a half x, inner is minus a half x, so that's minus x, that's what we wanted. And then plus a quarter. So let's look at what we have over here. We have x squared minus x minus 3 equals 0. We hope that that equals then x minus a half. Now we know what x minus a half all squared is. It's this. It gives us a quarter that we don't want. So it's minus a quarter minus 3 equals 0. X minus a half all squared. I'm going to put this just in quarters. We tend to like top heavy fractions a wee bit better as we get further on with our maths. So that's a 12 over 4 and that's a 1 over 4. So it's minus 13 over 4 equals 0. X minus a half all squared equals 13 over 4. X minus a half equals the square root of 13 over 4, and of course that's the plus or minus version. I didn't need the bracket there, but that's okay. I'm now going to add a half to both sides. So x equals a half plus or minus the square root of 13 over 4. Now this tidies up very slightly. We just need to be careful here. 13 doesn't have a square root, so we're just going to write it in terms of surd form, root 13. But the square root of 4 is 2. So that's actually going to give us x equals a half plus or minus the square root of 13 over 2. And we now have a common denominator. So it's going to be x equals 1 plus or minus root 13 all over 2.